One of the things I've noticed as I've gone around to stamp and check your homework logs, many of you are showing the work in a neat and orderly way, but some have shortcutted things perhaps too much. So as we go on to topic 2.8, and again we ask you to highlight that. This will be the quiz me on section 2.8, part 3. And what they're asking us to do is to solve the inequality, graph, and give the interval notation. So again, step 1 is to write the example out. And again, you want to try to keep your variables positive. So I'll do it, instead of transposing it, I'll do it the other way. I'm going to add 3x to this side, 3x to this side. So this then gives me an x. By keeping them positive, my x is positive. Now I'm going to subtract 18 from this side and 18 from this side. And again, you can use transposition. Now here, this becomes a 6. So you've written the example, you've shown the steps to get to the next step. I don't have to divide anything. Now what I need to do is to make a number line of this. The number I'm interested in is 6. And here it says x is less than or equal to, so we use a bracket. Darken this line. So now there's the graph, and then right from the graph you do your interval notation. Well, this is coming from negative infinity, and we always use a parenthesis. Don't forget to put the negative there, comma, goes up to 6, and we put a bracket. All right, next example. Now in this next example, we have a negative 3/5 x is less than or equal to 9. So we want to get our x to be positive. So what can we use here? Well, we can use the reciprocal. The reciprocal of this is a negative, just flip this over, 5/3, a negative 5/3. Now notice you're multiplying this by a negative. So to keep this inequality true in our answer, we must reverse the direction of our inequality sign, because we're multiplying by a negative. So negative times negative gives us a positive x, and these just all cancel out. Multiplying any number by its reciprocal gives us a 1. Now here the 3 will go into 9, and that will give us a 3. So 3 times negative 5 is a negative 15. So when we draw the graph of this, again, the number we're interested in is a negative 15. And what does it say? X is greater than or equal. So here it's going to be a bracket, because x is the negative 15 is included in the set. And then in interval notation, it starts at a bracket, negative 15 coming right from the graph, and up to towards positive infinity. And infinity is always with a parenthesis. Okay, we'll do one more. And we still want to solve, graph, and then write it in interval notation. So here we have one that is with a fraction. So looking at this, to get rid of our fractions, we're going to have to multiply it by what? a 21. So multiplying both sides by 21 keeps it equivalent. Here the 21s cancel out nicely. Here 7 will go into there once, 7 will go into there 3 times. So now we get 8 times x is 8x. 8 times 2 is 16, is less than. Now there's a 3 there. 3 times x is 3x. Gotta watch out for that. And then 3 times 3 is 9. We want to keep our values positive if we can. So we're going to subtract 3x here, or just transpose. This gives me a 5x. We're going to subtract 16. This will give me a negative 7. Now divide both sides by 5. We get x is greater than a negative 7/5. Drawing your number line, a negative 7/5. What do we put here on our number line? A parenthesis. Since it's greater, it'll face towards the right. Darken that, and that is your graph. Interval notation starts with a parenthesis, and it goes to positive infinity. So again, this is what we're looking for. You've written the problem, you're showing the solution, and then you're doing the graph and interval notation. This is what I want to see in your homework logs. And again, many of you are doing it this way, but some were leaving out some of the middle steps, which is not good. Okay, there's a little summary.